All right, here we go. Okay, so any questions over the homework? Last class we did the toolbox of functions, right? And then you had to go home and try and graph these things and anything? Yes.
The one where you wanted it for the homework that was asking us whether it was functional or non-functional.
Yes.
Then it was asking for domain and range.
Just all I wanted was function, no function.
Oh,
Yeah. Yeah, because we didn't talk about getting domain and range off a graph.
So what you're saying is I'm an overachiever.
You are an overachiever. I knew that already though.
That's true.
Yes.
Just wanted to make sure that we're on the same page.
Wait, number 69 on 2-4? Okay, the f of x is 1/2 x plus 3. Okay, so you want, but you're talking about number 69, but plugging in 2c. All right. So on number 69, it is, they give you a function, f of x equals 1/2 x plus 3. And they ask you to evaluate the function at 2c. So that means they want you to plug 2c in wherever you see an x. So wherever I see an x, I replace it with 2c. So it will become 1/2. Now here's my replacement. 2c right there plus 3. And then you need to multiply. So when you do 1/2 times 2c, the 2 and the 2 here cancel. And all you're left with is a c plus 3. And that is all. Is that okay?
yeah, go back to the book. It had a different answer. It was, I think, 1/2 C plus 7 over 2.
Whoa. There may be a mistake. You might have been looking at the next one. Okay. So we're good then? Okay. Yeah, we're. Oh, yeah, I see it. C plus 3. Okay. Any others? I got it. I'm good. Feeling good about it. You want to do the f of c plus 1? Okay. So just remember, in this problem, this is what you're using as your function, right? So anytime you're asked to evaluate a function, you need to actually have the function explicitly defined. It is right here. So if we want to plug in f of c plus 1, then again, we're going to take our c plus 1 and make that our x. So we have 1/2. Then I'll do it in parentheses, c plus 1, and then plus 3. This time, we have to distribute the 1/2 through the parentheses like this. And it's important you have to have that in parentheses. If you don't, then you won't distribute, then it'll be wrong. So I multiply 1/2 times c is just 1/2 c, plus 1/2 times 1 is 1/2, plus 3. And now what I need to do is combine these two together. Right? Combine those two together. Do you want to scoot back, or y'all okay? All right. Let's share this coffee. Okay, now 1/2 plus 3. Let's do that real quick. How do you do 1/2 plus 3? You write it as 3 over 1, right? Get a common denominator, which is 2. So multiply top and bottom by 2. On the right, you multiply the fraction 3 over 1, 2 on top, 2 on bottom, and then add straight across. 7 over 2. Keep the denominator the same. So we will have 1/2 c plus 7/2. We're going to get more practice with this today.
Yay.
Yep. It'll be a little more complicated, but we'll get practice. Okay? All right. Let's start with the last bit of material that's going to be on your exam. Oh, by the way, before I forget, I'm going to send a review out. I'll write this down. I will send out a review via email by Friday, 2 p.m. I'll probably send it out today if I get time. But definitely by tomorrow, 2 o'clock. I'll email it to you. And in our courses, in files, I'll have it in there also. Now, that's just so you can have the weekend to look over. I mean, because we're going to finish today all the material, so I anticipate you'll be able to do the entire review over the weekend. And that way, when you come in on Tuesday, if there's something off the review that you just didn't understand, then you can ask. Then on Tuesday, sometime, I will send out the solutions. But you're not going to get the solutions till next week. That way you work on it yourself. Okay? And this review will be like a homework assignment. Okay? It will be, I'm going to say it's due Tuesday, but it's not actually due. Like, you don't have to complete it. If you're stuck on something, then the idea is that you come in and you say, I just couldn't do this one, or I'm not sure about this one. But I want to come in on Tuesday and everyone have looked at it. Okay? You're good to go? Yeah, so you'll be good to go. All right, 2.8. So we skipped 2.5 in the book, just so you know. We skipped 2.5. We did 2.6, which was the toolbox of functions. It has us in our syllabus or in our schedule, has us covering 2.7. I'm going to spare you 2.7, all right? It's maybe at the end of the semester, if we have time, we'll come back to it, but we can live without it. 2.8 is called the algebra and composition of functions. The algebra and composition of functions. Now, here's the way I'll kind of introduce this idea. In the beginning, right, when you first were introduced to mathematics at a very, very young age, you were taught about numbers, right? And you were taught about 4 basic operations between numbers, right? These are called the arithmetic operations. The arithmetic operations are as follows: addition, subtraction, multiplication, division. I'm using a dot for multiplication instead of the little x, right? Those are the 4 arithmetic operations. Basically, you were told, look, if you have 2 numbers, you can always add them together, right? You have 2 numbers, you can subtract them. If you have 2 numbers, you can multiply them. If you have 2 numbers, you can divide them. What we're going to talk about today is using those same 4 operations on functions. So instead of giving you 2 numbers and saying add them, what if I give you 2 different functions and say add them? What do you do? And it's pretty natural, like it is what you think it's going to be. You just add them up. So when we do the arithmetic operations, I'm going to say ops on functions, here's how to work. If you are given 2 functions and I'm going to call those 2 functions f and g, but they could be g and h, or whatever you call the functions, but just you're given 2 functions f and g. Then here is how we notate, I'm going to underline the word notate, the 4 arithmetic ops. Okay, here's how we notate them. So the important thing here is this is a new notation. All right, notate. That's the key to this. It's a new notation. How do I communicate to you that I want you to add those two functions together? So here's how it's done. With addition, I do this. I write f plus g in parentheses of x. So if you see that, that tells you add the functions up. That makes sense, right? Not any magic there. It's just take f, add g. So by that definition, with that notation, it means you take the function f of x, whatever it is, add to it the g of x, and be done. And then subtraction, what do you think's different? Instead of f plus g, I'll write f minus g. Now, we have to be a little careful with subtraction because addition is what we call commutative, right? If I ask you to add two numbers, like 3 plus 4, it doesn't matter if you do 3 plus 4 or 4 plus 3, right? You can swap the order around. Yes? With addition. With subtraction, is it the same? If I do 4 minus 3, is that the same as 3 minus 4? No. So when you write down here f minus g, right? The f function comes first, then you take away the g function. I'm trying a different highlighter color to see if it works better. I guess it's okay. Let's see. I take the f function, minus g, and I'm done. I'm also going to point out at this point that we must be very careful with that minus sign in the middle, right? Because if I say subtract a function, if that function has 4 terms in it, you have to subtract each term, which means that negative will have to distribute. You'll see when we do some examples, but that's the thing that gets most people on the subtraction. That negative will change everything that, whatever g is, it's going to change the signs of everything. Yep. So just be careful with it. Now, the next operation would be multiplication. And with multiplication, the way that I'm going to let you know that you need to multiply two functions is I'm going to write f and g right next to it with nothing between them. And we call that implied multiplication, meaning that there is a dot between those, but we don't write it. So that means multiply. And so what you'll do is you'll take your f function and you will dot it with the g function. You'll multiply it. This one is also a little tricky because if f has more than one term and g has more than one term, then you're going to wind up foiling or expanding or something like that. So our use of parentheses is going to be important here, as you'll see. And then the last one is division. So if I want you to divide two functions, I write f over g in a big parenthesis like this of x. And of course, that means you take the f function and divide it by the g function. And I'm going to put one little thing to the side of this. You can do division of two functions as long as your g function is not 0, right? If your g function is 0, then it's undefined and you can't do it. Now, with multiplication, would it really matter the order on multiplication? Like the f and the g, could I flip them? Yes, because multiplication is commutative. Division's not. So division, if I write the f on top of the g, you must put the f on top of the g. So you'll want to be careful on your test because I may put g on top of f, and everyone's thinking, oh, division's always f over g. It's however it appears here is going to dictate what you do. Okay? These are the 4 arithmetic operations. So let's go ahead and do an example. The first thing I'm going to do is give you 2 functions. So I'm going to say let f of x be equal to 2x minus 3. And let's let g of x be equal to x squared minus 4. So I've given you 2 functions, right? There they are. Now here come the questions. First, find this. So on a test, that's what you would see. I wouldn't give you anything else right there. So you need to know what that means. So what does f plus g of x mean? Add them up, right? Add them up. So I'll do my answer in blue so you can tell the difference. So here's what my answer would be. I'd write f plus g of x equals my f function, right? F of x plus my g of x. I don't know why it keeps doing that. I'm writing too fast. Now, what is the f function? So I'm just going to rewrite what f is right here. 2x minus 3 plus, now what's my g function? X squared minus 4. Right? And now all I have to do is look at that and collect like terms and put it in descending order, and I'm done. There's nothing more to this, all right? Just add them up. So let's collect some like terms together. The only thing that I can collect is the negative 3 and the negative 4, right? That gives me a negative 7. I can't put the 2x with the x squared. So what would be the correct answer in descending order? Highest power of x down. Yep, that's it. X squared plus 2x minus 7. That's it. Don't set that equal to 0 and try and factor. That's not what we're doing. All we're doing is we're figuring out what these 2 functions are if we add them together. Now, I want to do a little experiment because looking ahead to what we're going to do at the end of class, I want you to understand how addition works, all right? What's really happening. So what I'm going to do is I'm going to try and split the classroom up here. And let's just say we'll go just these 3 tables right here. Y'all are the f function, okay? And everyone over there, y'all are g. Got it? So let me ask you a question right now. F function. What's f of 2? 2, y'all all agree? What's f of 2? G, f of 2? Do we need to bring another table into the f? Is f of 2 2? Hold on, g's. Y'all be thinking about g of 2 over there. F of 2 is 2? Y'all agree with that? Where are you getting 2 from? If I ask you, what's f of 2? F of 2. Go. You're the f function up there. Plug 2 in. What are you? 1. 1. Right? Look, go up to the f function right here. I'm highlighting the yellow. Plug 2 in right there. What do you get? 2 times 2 is 4. Plus 1, or minus 3 is 1, right? So f of 2 is 1. Got it? What's g of 2? 0. Got it? So separately, if we look at the f function by itself and plug 2 in, we get 1. We look at the g function separately, have them plug 2 into that function, we get 0, right? So if I ask you, what is f plus g of 2? If I ask you, what happens if I take f plus g of 2 then I'm saying take the answer here, right? 1, right? And add to it what? 0. And what should we get? 1. So this should be 1, right? If I take them separately and add them together. But take this function, take this function right here and plug 2 into that one instead. And what would you get? Plug 2 in here. 2 squared plus 2 times 2 minus 7. So you get 4 plus 4 minus 7, which is 1, right? Isn't that the same answer? It's the same answer, right? What I'm trying to get you to see is this. The way that addition works is it takes the answer, it takes a number, right, like 2. It plugs it into F and it plugs it into G and then takes the two answers and adds them together, right? You'll see why this is important later. Each function gets 2 and spits out an answer and they add them. With me? This function that we got as an answer does that for us. See, if you look at this boxed answer, we don't have to look at it as going into F and going into G and then adding the two answers. This boxed one does that for us. It already does the addition all in one. Okay? Does that kind of make sense? Okay. So now if I ask you, what's F plus G of 5? I could say, okay, F, y'all tell me what you get when you get 5, right? Then G, tell me what you get when you get 5. And then add them together. Or I could just plug it into this and it would be the same thing. So I'm going to go the short way. It's 5 squared plus 2 times 5 minus 7. That's 25 plus 10, 35, take away 7, 28. We should get 28. Now let's just check it. F, if I hand you 5, what do you get? G, if I hand you 5, what do you get? So let me go back up to here. If we plug 5 into F, what should we have gotten? 7. And if we plug 5 into this one over here, we get to G, you get 21. What's 7 plus 21? 28. So see, that our boxed answer did that already. I hope that makes sense. You can combine functions together to create new functions. And you can look at this as like, if you have a company and you're talking about your revenue or something, and you're talking about, okay, well, I have a function that tells me how much is coming in from my sales at the mall, and then I have my internet sales, and each one of these is a function. You put them together, you create this total revenue function, which is a combination of all these different ones. I don't know if that makes sense, but okay. Second one. Let's see. What happens here? What if I ask you for this? So I'm asking you to figure out what G minus F of X is. So here's the answer. G minus F of X means I'm going to subtract the two functions. And which one will go first here? G, because of the order I put it in, right? So I'm going to take G of X, I'm going to subtract F of X. Now G of X, I can just write down what G of X was. What was G of X? X squared minus 4. Yeah, we're using the same function for all of these problems. So G of X was X squared minus 4, right? But now I'm going to subtract from it F. What was F? 2x minus 3. But is that correct? There's something wrong with that. This is what I told you need to be careful with. The minus sign, right, says subtract all of G, which means that the minus sign is going to have to distribute, which means you need to put that G in parentheses and then pass your negative through. Your F in parentheses. Thank you. So it'll be minus 2x, then what? Plus 3. Okay, don't be the one that makes that mistake on the test. Be very careful with that. That's supposed to be a star. Forget it. That's a star. Try a different one. Better. Still not very good. Okay, so we're not done, right? We need to combine like terms. So let's go x squared minus 2x, and then this time minus 1. It's a little different than the one we got before, right? Now this new combination of these two functions creates this one. And what it's really doing is if we plug a number in, it's plugging that number into both G and F, and then it's subtracting F's answer from G. So let's try an example just to see that this works. Let's try, what would G minus F of 2 be? And let's do it the way where it's separated. So G again, what do y'all get when we plug 2 in? 0. And F, what do we get when we plug in 2? We get 1, right? So what would happen if we took G's answer, 0, and subtracted from it F's answer, 1? We should get negative 1, right? But instead of doing that, let's just plug it into this. Plug in 2 into that. And what do you get? 2 squared minus 2 times 2 minus 1. So you get 4 minus 4 minus 1, which is negative 1. So that does the same thing, doesn't it? Okay. 2 down, 2 to go. Yeah, now multiplication. I'm going to start a new page. So for our third operation, multiplication, I'd like for you to do F of x. What does that mean?
F times A.
It means F times itself, doesn't it? That's what it means. So I need to be able to interpret F of x to be, take my F of x function and multiply it times my F of x function again. Right? That's what it means. You could write it squared, yes. Now, I'll show you how you do that in a second. So what is the F function? 2x minus 3. I'm going to take it and multiply it times 2x minus 3 again. But that is completely wrong unless I do what? I need to FOIL it, right? Which means I need to have put both of these functions in parentheses to imply the multiplication. Right, there's your F function times itself. And now let's expand that. So I'm going to multiply 2x times 2x, which gives me 4x squared. And then 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x again. And our last multiplication, negative and negative, is positive. So positive 9. So we have 4x squared minus 12x plus 9. Now, what is this function doing? F times itself, right? F times itself. So let's try this. What would F of 2 be? Now let's step back and let's just ask F again. F, what do you get when we plug in 2? 1. Now multiply 1 times itself. 1 times 1 should be 1. Okay, let's see if it works. Plugging 2 in to this new function we created, we should get 1. Let's see. 4 times, we're plugging in 2, 2 squared, minus 12 times 2, plus 9. Let's see. Order of operations, we do the exponents first. So 2 squared, that's 4. 4 times 4 is 16. 16, take away 24, add 9. Gives you positive 1. So it did the same thing. Now, I'm going to do another one. I'm not ready for division. I want to go to something a little more classic. This is something you would probably see in the book more often. fg of x. That means you take the f function, you multiply the g function, right? So I'm going to take my f function, multiply my g. That's what it means. F was 2x minus 1. G was x squared minus 4. I'm multiplying them, so I put them both in parentheses, right? And then I distribute, or expand, or FOIL in this case. So do your foiling there and see if you get what I get here. Anybody else get that? Now again, what this does is it's taking the two functions separately, f and g, and then multiplying their two answers together. So let's use 2 because we've been using 2. If we plug 2 into f, we got 1, right? We plug 2 into g, we got what? 0. And we multiply those two answers together, you get 0, don't you? So when you plug 2 into this, you should get 0. You should. Let's see, what would it be if I plug 2 in? 2 times 2 cubed minus 2 squared minus 8 times 2 plus 4. 2 cubed is 8 times 2 is 16. Minus 4 minus 16 plus 4. And that's 0. Now you may argue with me, hey, well that's more complicated. I agree, but that's not the point. The point is that I want you to see that these functions, what it's doing is it's taking the numbers separately and then putting together, either adding, subtracting, or multiplying, right? Was it minus? Why didn't y'all say something? It was minus 3. Yeah, that worked out coincidentally. Well, this math is right based on that, right? So let me do this. To fix this, watch what I'm doing. I'm just going to do this. Right here, let me just change that f of x is 2x minus 1 and g of x is still the same. So I just changed it just for that part 4. Let's just say that the only thing changed, I used 2x minus 1 as my f. That way I don't have to go back and redo the whole thing. Yeah, kind of picked up on that already. All right. So the last thing to talk about is division, right? Division? Did I go too fast or is that all right? You need me to go back? Okay. So let's use, just so we're clear, let's let the f of x be what it was originally, which was 2x minus 3, and the g of x will stay the same, just so we're clear. Now I want you to find f over g of x. This one for us is going to be the easiest one, because all you have to do is say, well, that's f of x divided by g of x, which means you take the f, you put it on top, you take the g, you put it on the bottom, and you box it. Okay? That's it. No, that's it. There's nothing else we are going to do with that. Now, the only thing I could ask you is what what's the domain of that function? Well, then we would go back to the idea of, okay, with domain, you can't have division by 0, right? So you'd look at that denominator, and you would say, right, x squared minus 4 can't be 0, so you'd set it to 0. You get two answers, 2 and negative 2, right? I mean, that's the only thing that I would add in addition to this. What's the domain? Okay, that's it. Now, I'm going to give you a problem to work on together in groups. These 4 operations. We still have one more thing we have to do today, but I want you to just practice with this because these examples were relatively easy compared to what I'm going to give you now. So I want to see how you do with this. Okay, here you go. This is for you. Enjoy. Let f of x be equal to x squared plus 3x minus 1 and g of x, that's a comma, g of x equal to x cubed minus x. Yeah, I'll just stop there. I don't want to be too, yeah, that's good. Okay, here are the instructions. Find f plus g of x. Find f minus g of x. And find f times g of x. And I won't even have you do the division because it's too easy. You're just putting something on top of the other one. Just those 3. Okay? I'm just going to pause our video.
It only comes out to 4 terms, not 5, right?
I believe so, only 4, because some of them combine.
The x cubed cancel out.
That's right. Okay, check this out. Whoa. Why does it keep doing that to me? Okay, FG means you take your f of x and you multiply your g of x. That's what that means, right? So that means I'm going to take my first function f, which is x squared plus 3x minus 1, multiply it times the other one, x cubed minus x, but then I have to put them in parentheses, right? That's the multiplication I'm going to do. Now, let me work this out. The reason I gave this to you is because a lot of students have trouble if it's more than 2 terms in 2 terms, because they learn FOIL, but then anything past that, it's too much. So what you do, you start with x squared, okay? You start with the first term. You take that, you multiply it times everything in the other set of parentheses. Okay, let's do that first. So I would get, let's see, x squared times x cubed, x to the 5th. X squared times negative x, negative x cubed. Okay, that's it. That's the first multiplication. Now, you move to the second term, positive 3x, and you do the exact same thing. Here and here. So 3x times x cubed would be positive 3x to the 4th. Positive 3x times negative x, negative 3x squared. Do y'all see that? Now I've got too many lines up there, so I think I'm going to get rid of some of those. Now I go to my last term, negative 1, and distribute the negative 1 through the parentheses like this. So you get negative what? X cubed and plus x, right? Because negative times negative is positive. And that's it. Can someone hit the light? I think it's the, I don't know which one it is. The middle one? Yeah, I think that's where we were. It's a little easier to see the board. Now I collect like terms. X to the 5th. How many x cubes do I have? Negative 2, right? So X to the 5th I've done already. My cubes I've done. Let's see. Oh wait, I forgot my 4th. Oops. I need to put it in descending order. Let me get that plus 3x to the 4th in here. Then my minus 2x cubed. And then minus 3x squared, and then plus x. So there's 5 terms. Did you figure out, because you had 4, okay, we're good? Okay, that all right? Now look, more like in general, just so you know this, all right? And let me offer this as a bonus question, all right? Bonus. To be turned in next class. Everyone always wants to know, what can I do for extra points? This is something you can do. What's x to the 4th plus x cubed? It's a 4. Plus x squared minus x minus 1 times 2x cubed minus 3x squared plus x minus 5. Now look, the idea here is that it's a procedure, it's a process, okay? You do the same thing that we just did. You start with the first term, right? And what do you do with that first term? Distribute to everything in the other parenthesis. Once you've done that, you move to the next one, distribute. Next one, distribute. Next one, distribute. Next, and then get all those terms together and add them up. You're actually going to have 1, 2, 3, 4, 5. 1, 2, 3, 4. You're going to have 20 terms. So you might want to write sideways, like landscape on a piece of paper, because you're going to have 20 terms that you have to add together. It's a bonus, okay? It's a bonus. So you either do, but what this does is it helps you to understand how to properly expand polynomials. That's the proper procedure. That's why I don't teach FOIL, right? FOIL would not work here. Did we talk about that? Yeah. I'm just showing you something. When you're taught FOIL, right? Did I talk about this? Did I say this? When you're taught FOIL? No? When you're taught FOIL, you're taught what? First, outer, inner, last, right? But what are you actually doing? Check this out. If we do our procedure, right, the one I'm showing you, you start with the x and you multiply the x times the first thing over here, right? Well, isn't that f? Isn't that first terms? Okay, and then in what I'm showing you, then do this, right? But isn't that now outer? And then if you follow what I've shown you, the 2's next, and the 2 gets distributed through. That would be inner, and then last would be the last one, right? So FOIL is what I'm showing you. Just FOIL only works for 2 and 2. I can think of another F word that you probably think of when you see something like that. Okay, now let's look at our last thing for today. Composition. Now, composition, I should say this. We looked at 4 arithmetic operations: addition, subtraction, multiplication, division. We're all comfortable with those. We've been doing them our whole lives on numbers, right? Composition is our 5th operation, right? We had the 4 already. It's our 5th operation on functions. But what's different about composition, the reason I've saved it for the grand finale here, is because composition is something you have never seen with numbers, because you cannot do composition on numbers. Composition makes no sense with numbers. It only makes sense with functions. So here's the way composition works, all right? I'm gonna start by talking about it in our example, like f and g, and then we're going to define it. So remember, we had said let f be, and I'll try and get this right, 2x minus 3. And we said let g bx squared minus 4. That's what we had started with when we started talking about arithmetic. And everything we did with addition, subtraction, multiplication, and division, whatever I plugged in, like 2 was a number we were really using a lot, right? Whatever that number was, that number went to both functions, right? F got it and G got it, and then they went together, either add, subtract, multiply, or divide, right? Yes? Okay. Composition works this way. I'm first going to figure out what's f of 2. So f, tell me what happens if I plug 2 in to you. You spit out 1, right? Now notice what's going to happen now is I'm not going to say, okay, G, now I'm going to give you 2. What I'm going to do is I'm going to give you their answer. So what's their answer? 1. Take that answer, G, take that answer and tell me what happens when you take 1 and plug it into G. It comes out as negative 3. Okay, now I want to draw a better picture of this. What happened first is we started with the number 2, right? 2 went somewhere, it got sent to the number 1, and then that number got sent to the number negative 3. Right? That's what happened. Started with 2, it got changed into 1. Who changed 2 into 1? Who did that? F did that. And then what function changed 1 to 3? G. Do you see that this is not taking the number 2 into both functions and then putting them together? It's passing it through one and then through the other, almost like an assembly line or something. First you weld it, then you paint it or something. You know what I'm saying? It has to go through the both functions, one after the other. Now, that's not the only way we could have done it though, right? What if I had taken the 2 and I had given it to G first? What if I handed the 2 to G? So G, what happens if I hand you 2? You spit out 0, right? Now that answer, let's pass it through F. And you get negative 3. Now, the fact that those answers are the same is just a coincidence. They won't always be the same. Let's do another example, just so you can see that. Let's take same thing. Let's take the number. Let's take 0. Let's pass 0. Oh, you know what? Yeah, 0. Let's do 0. Let's pass 0 through F first. What happens if if I hand F 0? What do you hand back? You hand back negative 3. Now let's take that and send it through G. So G, what do you do to negative 3? What do you spit back? G. Is it 5? It's 9, right? You square negative 3, it's 9, and then you take away 4, so you get 5. Right? Let's do the 0 getting plugged in again, but this time let's plug it into G first. So 0 is going to go through G. And then G sent, where does G send 0? Negative 4. And then let's pass that on to F. Where does F send that? You have, remember, F is 2 times x minus 3. So what's 2 times negative 4? Negative 8, take away 3? Negative 11. So see, you don't get the same answer here. Do y'all see this? I'll separate these here. Right, on the first pair up there, 2 went into F, then went to G, it came out negative 3. If we do it the other way, 2 goes to G, then F, we got negative 3. And we might think, oh, wow, it's always going to be the same either way. This one shows it's not. 0 goes into F, then G. That's going to be 5. If you put 0 into G, then F, you get negative 11. This is the idea of composition. All right? Now, there's nothing that says that we have to do F, then G. You could do this. Let me see. Couldn't I do this? Couldn't I start with the number? Let me pick, how about 5? Couldn't I send that through F and then back through F? So what would happen if I give F 5? 7? Now take that answer, put it right back through the function again. 2 times 7, take away 3, 11. You see that? And there's nothing that says I couldn't send it back through again and have a third arrow going. So composition can be done, 2 functions composed together. You can do a function composed with itself. You could do it as many times as you want. Let's do the same thing with G. What would happen if I take 5, I pass it through G, I think this might be big, and then pass it through G again. So the first time it goes through G, you get what? 21. Oops, sorry. 21. And then pass it through G again. So you have to do 21 squared minus 4. What is it? Y'all agree? So do you see why you can't do this with numbers? You see why you can't compose numbers? Like if I say take the number 4 and compose it with 3. You can't send 4 through 3 and... You see what I'm saying? Only functions can do this. Now, let's get to the notation. Notation. How would I let you know notation for composition? So how do I let you know that I want you to compose 2 functions? Here's how it's done. If I write this, F, with a little O between them, and then G, and put it in parentheses, of X. That little O represents composition. And what it means is that you take the F, and inside of it, you put the G. That is the definition of composition right there. And below this, I'm going to draw you a picture of how what's being taken where by who. All right? With this red picture, what's happening is this. You're starting with something. It's going through one of these, and then it's going through the next one and coming out over here. So watch what happens. We start with something, right? What we start with here, I don't know what it is. X, right? Who gets X first? Can you tell by what I wrote up there? Who gets X first? G gets it first, right? G is going to get X, and it's going to spit it out right here as what? We don't know. G of X, right? It's just something. And then who gets that answer? F. And F spits that out as, well, I don't know, whatever F of G of X is. That's the picture of that composition. Now, I've heard instructors, and I've even heard a few people today say this, fog. Fog. That looks like F. That little F of G of X thing over there looks like fog. Right? Fog. It is fog. Whatever. That's fine. It's cute if you remember it that way. Whatever. But here's the problem with fog. It's the same. I don't teach fog because for the same reason I don't teach FOIL. Fog works only for if you want to send it through G then F, right? What happens if you want to send it through F first then G? Then teachers will teach GOF, okay? But I've shown you that there's nothing that stops you from sending it through F then F. So then it's FOF. Or you could do G, then you could call it GOG. And then you could do F, then G, then F again, and then G. so you could pass it many times. So then you're like, goff, off, off, goff. Who cares anymore? At some point, it gets silly to try and label it all. You know what I'm saying? It's better for you to just understand, like, what's happening.
That's okay, right? Just saying.
Yes, you could.
Hey, what would that be?
Fuck. Or K of K.
You know?
All right, y'all are getting vulgar now. Y'all are terrible. I shouldn't include everyone else in that table. I told you, I warned you in the beginning of the semester about this table over here. All right, so I think it's time for an example, don't you? Because we're running out of time. I'll start a new one here. Let's let f of x, we're going to go ahead and stick with our same functions. And I want us to first find fog. No. I want us to find that. Now, I never told you how you would say that, so I'm going to put that over here. The way you say that is f of g of x. That's the way you'd say that in words to someone. That is f of g of x. By looking at that, though, you need to know, okay, maybe on your cheat sheet or something, you need to know that that actually means this. It means the f function, inside of it the g function, right? That's what it means. So the blue would be where I start my answer here. So what I'm going to do first is I'm going to rewrite f, but instead of writing g of x inside, I'm going to put what? What is g of x? X squared minus 4, right? So all I've done is just a complete replacement of what g of x is defined to be, right? That's what g of x is. So I replace that g of x with g of x. But now I'm supposed to take that and plug it into what? Into the f function, right? So this thing right here is now really the x in my f function, isn't it? It's what I'm plugging in there. So now I will drop the f and I will write what the f function is. So what is the f function? 2 times whatever I'm plugging into it. What am I plugging in? X squared minus 4. And then, don't forget the rest of f. Minus 3. Does everybody see the f function sitting inside of the g function there? Okay. Now let's clean that up by distributing the 2 through. And we get 2x squared minus 8 you get 2x squared minus 11. Okay? Now, in this picture, or in this problem, who got x first? G, right? So let's go back and look at something. The page I had before this. Where is the one with all my arrows? Here it is. Let's do the 0 one. I'm talking about this one right here. And that one, G gets it first, right? Okay, so let's try it. Let's hand G 0, right? They spit back negative 4. We hand that answer to F. They spit back negative 11. Right? Negative 11. If we plug in 0 through this composition, we should get negative 11. Now, come back to here. This is what we got algebraically. What happens if we plug 0 into this? You get negative 11. See, it's taking care of the composition for you, all in one step. Okay? That's what we've done. We've created a new function that does the composition of those two. All right, the last one for today is now let's do g of f of x. So this means g, and inside of g is f. You don't have to remember that if you write it on your formula sheet that you're allowed to have on your test, right? But you need to write it down if it's not in your memory somewhere. So by definition, all I'm going to do first is replace the f with whatever f is. 2x minus 3, right? So all I've done is replace the f right here with what it is. But then I'm supposed to take that and plug it into g. So that's going to go into the g function. What does the g function do? It squares it, right? So I'm going to write 2x minus 3. I'm going to square it, and then minus 4. Does everyone see the g function there? If you squint your eyes, that green is the x. So that's basically x squared minus 4. But the green's been replaced with what we're plugging in, which is the f function. And now you have to expand this. So that means you have to FOIL it. 4x squared minus 12x plus 9 minus 4. So this right here, I did this. And I did my FOIL, right? I did it mentally, and then I collected like terms, and that's what I get. And then finally, put that minus 4 on the end. I'm not expecting you would do that mentally. I'm just saying you could get there, right? All right, that's the answer. So now, who gets x first here? F gets x first here, right? So let's see. Let's try 0 again. If 0 went through f first, they spit out negative 3, right? Negative 3 went to g. Negative 3 squared is 9. Take away 4 is 5, right? So 0 through comes out 5. What do you get if you plug 0 into this one? You get 5. So it takes care of composition the other direction. All right, here's what we need to do. We need to do attendance, and we need to do your homework. So I'm going to tell you the homework first, and then attendance. For homework, this is page 265. And let me see here. Let's do 35 through 45 is going to be tough, but I'm going to see what you do. 45 odds. And in the instructions there, it talks about domain. Skip the domain. They ask you about domain. Don't even worry about it. Skip domain. And then do 53 and 55. Skip domain also. So I'll tell you real quick what these are about. 35 through 45 is add, subtract, multiply, divide. 53 and 55 is composition both ways, f of g of x and g of f of x. Here's your book. I'm going to take a quick attendance.